Right now on the seafloor, a crab is walking toward the edge of a perfectly still pool. The water looks calm, almost inviting. It doesn't know that the moment it steps in, it will be dead in seconds and preserved whole for the next 8 years. A mile beneath the Gulf of Mexico, there is a lake. Not a cave, not a current, an actual lake sitting on the floor of the ocean with a surface you can see and a shoreline you can walk up to. And here's the thing that shouldn't make sense. It's a lake underwater, a body of water, resting inside another body of water, refusing to mix. If you were down there in a submersible, you could watch ripples move across its surface, exactly like wind crossing a pond. You could nudge it and watch waves roll out. You could even set your vehicle down on top of it and float, because the lake is so heavy it holds you up. So how do you get a lake inside the sea? The answer starts with salt, and a story that's older than the dinosaurs. Around 150 to 200 million years ago, as the continents were tearing apart, a shallow arm of sea got trapped in what is now the Gulf of Mexico. It baked, it evaporated, and it left behind a layer of salt up to 5 miles thick. That salt got buried under the seabed, crushed under the weight of the ocean and the rock above it. But salt under that kind of pressure doesn't just sit still, it creeps. It pushes upward through cracks, and where it reaches the seafloor, seawater seeps in and dissolves it. What comes back out is brine, water so loaded with salt that it can be 3 to 8 times saltier than the ocean around it, and salt makes water heavy. This brine is so dense it can't rise and it can't mix, so it does the only thing it can. It pools in the low spots on the seafloor, and it just sits there, forming a lake with a hard, mirror-flat surface. But salt isn't the only thing coming up through those cracks. The same fractures leak methane and hydrogen sulfide, so the lake fills with poison. There's no oxygen in it at all, and that's where it turns lethal, because to a passing crab or a fish, this pool looks like nothing. The brine is clear, the surface is invisible until you're right on top of it, so they cross it. And the instant they do, everything goes wrong at once. The lack of oxygen suffocates them, the toxic gas poisons them, and the salt yanks the water straight out of their cells. They don't get a second chance to swim back out. They die right there at the edge. But that's not even the strangest part. Because what happens next is that nothing eats them. The bacteria that normally rot a dead body can't survive in the brine either. So the bodies don't decay, they get pickled. Researchers have pulled crabs out of these pools that had been dead for an estimated 8 years, with their soft insides still perfectly intact. The only thing that changed was the shell. Over the years, the brine had dissolved the hard shell until it went soft and rubbery. A crab you could bend in your fingers, its body preserved like it died yesterday, which is exactly how one of these lakes was found. In 2014, a team led by Dr. Eric Cordes from Temple University was mapping the seafloor from a ship called the Nautilus. They were driving a robot along the bottom about 1,000 meters down, and they noticed a trail, a line of dead crabs scattered up a slope, like breadcrumbs leading somewhere. So they followed it. The trail ended at the rim of a lake nobody knew was there, a ring of brine ringed with corpses, sitting in the dark. They named it the Jacuzzi of Despair. The name isn't just for the bodies, it's because this pool is warm. The deep sea around it sits near freezing, about 4 degrees, but the brine inside is roughly 18 degrees Celsius, warmed from below. To a cold, exhausted animal in the dark, a warm pool must feel like relief. That's the trap. The warmth draws them in, and the warmth is the last thing they ever feel. And here's a question the researchers still can't answer. How deep does it go? They lowered a line 19 meters down into the brine and never touched the bottom. So we don't actually know what's at the bottom of it. We just know that the fluid gets so heavy and so hostile that we haven't been able to reach the floor. Now, you'd expect a place like this to be dead in every direction. It isn't. Ring the edge of that poisonous lake and you find one of the most crowded neighborhoods in the entire deep ocean. The shoreline is packed with mussels, more than 2,000 of them in a single square meter, piled into beds several meters thick, and they're feeding on the very thing that kills everything else. Inside their gills, these mussels keep colonies of bacteria, and those bacteria eat the methane and the toxic gas seeping up from below. The poison of the lake is their food. They've turned the murder weapon into a meal. So the same brine that pickles crabs and suffocates fish is quietly running an entire ecosystem right at its own edge. Death on the inside, a garden on the rim. And these lakes aren't rare flukes. There's a basin nearby so large it holds more than 13 cubic kilometers of brine. On the other side of the world, in the Red Sea, There are pools heated by the planet's own volcanic plumbing to nearly 70 degrees Celsius, which brings us to why scientists care so much about a lake full of poison, because a cold, dark, salty, oxygen-free body of water is exactly what they think is hiding under the ice of Jupiter's moon Europa and beneath the poles of Mars. If life can not just survive but thrive on the shore of the deadliest water on Earth, then the odds shift. Maybe the places we've been writing off as impossible aren't so empty after all. So the next time you picture the bottom of the ocean as one flat, lifeless plain, remember this. Down there in the dark, there are lakes with their own shores and their own weather. And along the edge of the most lethal water on the planet, something is quietly, stubbornly alive.